So this is what it looks like when you get logged in. And if your credits went all the way down to 0 from a previous class, you have to go over here to billing and credits like so. All right. So what happens is you would come into MetaCTF, you would click on Cloud Labs, and you're going to see your balance is 0 right over here because you used the allotted free credits that we give out to all of the students. Then you select billing and credits, and it tells you your current usage, the time left, remaining balance, and then down here, you can purchase more credits via Stripe, okay? I'd recommend making sure this is not enabled, auto reload, because if you just let your VM run, it's just going to continue to charge you, and it should be disabled by default because right here it's bright red. It is currently disabled. Keep it that way. That is the default. I'm going to buy 25 more credits for everybody just so you can see it. So I go like that, takes me into Stripe, and then I can choose which credit card I want it to use, and then I can select pay. And you can get set up with Stripe, and I've already gone through. So now I have a lot of credits that I've purchased. Now you go back to Cloud Labs, and I've got 50 credits now because I bought some this morning. And then you can go into view and manage the labs. So some people may say, well, wait a minute, why don't you just give us free credits and have a way to get the endless free credit glitch? Because then I would be paying for all of your credits all the time. And I'd love to do that, folks. I really, really, really would. But if the VMs continue to run forever, let's say, I think it's about 16 hours, cost to me is about $4, which doesn't sound that much. But if I have students letting them run, or if they have a code, they can just keep putting it in, then I get charged for that. And that can add up really, really, really fast. So that code allows you to gain access to the classes, all of my classes for 16 hours. $5 should be able to get you through all the labs in 1 2-day class. No problem. So I did want to go through and just point out that the resources, if you're in our Discord server, which is where you really should be, you should be in our Discord server. We have the links to the Google Doc that gets you set up for the Cloud Lab environment. We also have the slides that I'll be presenting today. And then finally, we also have the GitHub repository where the labs reside. And for the record, we have people from time to time, they're like, oh my God, this GitHub repository is publicly accessible and anyone can access it. That is intentional, everybody. We are not playing the game with this class of that's my intellectual property and you must not do anything with it. And no. We're all about helping as many people as we possibly can in anti-siphon security training. So please keep that in mind as we progress throughout the sessions today. Big thanks to the Cybercall, kind of working with MSPs. We've spent all last week working with that. We also have a large number of sponsors from Blackpoint to Ninja to Datto to Cisco, ConnectWise, Huntress, Pax8, Scout, Sophos, ThreatLocker, and True Methods, who helped launch this initiative a few years ago. We also have some other very special sponsors that hopefully somebody like Megan could possibly get me a list of our sponsors and text it to me. I know that we have Barricade is awesome. We also have Networks. We have a SAS Alerts is cool. So we have some sponsors out there, but we're going to be sprinkling them out throughout this particular session as we move forward. So now we get into the question of what exactly is this? Like, what are we actually doing? Now, this particular class is designed to be a Bootstrap class. It's designed to be a class that'll help someone get set up in computer security and just getting started. Now, there's lots of compliance standards out there. As I mentioned, the Center for Internet Security is fantastic. The problem I have with Center for Internet Security, and it's not really a problem, is it's meant to be a comprehensive approach, starting with inventory, moving on to different types of protections and all of that. And that is all fine. And that is good. And it's wonderful. However, if you're in a situation where you're like, I have to get started with computer security right now. I am actively under fire right now. I am dealing with triage at this moment. This is the class for you. If you're looking for a class that can then cross map over to the critical controls, this class also cross maps to those. So it's not like they exist in two separate locations. They are very much heavily intertwined with each other. So if you're meeting here, you're going to be meeting the NIST 853, the ISO standards, HIPAA, CIS. These are the straight motherhood and apple pie that every organization should be doing in the world of computer security. So we're going to be covering what it takes to actually defend a network. Now, this class was put together by my brother and I. We did it on a napkin at some hotel at some con a number of years ago, where we developed the atomic controls. My brother has a completely different class on auditing the atomic controls, but this particular class is designed to take these 10 things that we're going to cover, and it's cross-mapped to the actual pen tests that we do at Black Hills Information Security. It's cross-mapped over to the actual incidents that we work with at Computer Security. So we have 10 topics plus backup and recovery, because you need to have backup and recovery. So you have to have these things in your security program to establish that base foundation for becoming compliant for ISO, becoming compliant for NIST, becoming compliant for the CIS critical controls. So all of that is represented here to get you rolling right away. Like I already talked about, it's about what works. What actually works. Not what somebody in a lab coat out in Washington, D.C. that's never defended a network, has never done computer security, thinks should work. Not what a vendor who's trying to sell you a product, as much as that is cool and it's wonderful, it's also very, very, very annoying. As much as vendors would like to sell you those things, a lot of times whenever they're developing compliance standards, you run into a situation to where what they're selling you isn't directly related to defending networks. Instead, we are pulling it back to what would have stopped Black Hills Information Security pen testers from successfully breaking into corporate environments, into government environments, into DoD environments, into international environments. Every single test went through each of the critical findings that we were successful for breaking into a company, and looking at it from that lens. What would have stopped us is what we basically set up to work with. So here's what we have. These are going to be the controls that we're going to be working through. And as I said, my brother has a separate class, Brian Strand. He's my brother. He's not my son. He is also a completely separate and different person from me. We have these different controls. Number one, application allow listing. Just out of curiosity, what do you think is a problem that exists with application allow listing? If you look at application allow listing, a lot of organizations are terrified of application allow listing because they're afraid that they have to go through and they have to uniquely identify every single application by vendor or by hash and choose whether or not they're going to allow it. You don't have to make it that hard. It doesn't have to be that difficult. You can do it much easier than. We're going to show you how to do that. Password controls. But this basically boils down to long, strong passwords and also using multi-factor authentication. We'll be talking about multi-factor authentication with tokens. We'll be talking about like Google Authenticator. We'll be talking about password managers. And then we're also going to be talking about the very heavily maligned SMS-based two-factor authentication as well. So sit tight. That's going to be getting there as well. We're going to be getting into egress traffic analysis, actually watching what is leaving your environment through your firewall, through domain filtering, through DNS filtering, and yes, through tools like network detection response tools like Rita and AC Hunter Community Edition. Then we have user entity behavioral analytics, taking log analysis and making it much more robust than just simply looking at the various logs that exist in an organization, but trying to look at how those logs actually interact with each other at a macro level. Getting into advanced endpoint protection. How do we do a solid EDR? And what are the things that you should be looking for in a solid EDR? We'll be getting into that as well. How do we do logging appropriately? Your logging, your UEBA is only as good as the logs you feed it. So we're going to be spending a lot of time discussing things like Sysmon. What are the appropriate 6 event IDs that you should be looking at in your domain controller and logging in your active environment as well. We're discussing host firewalls. Before we get into that section, a simple question. Why is it your computer systems are more secure when they're in a coffee shop than they are in an Active Directory environment? I think that that's very tragic, right? Internet allow listing. How can we set up this filtering? This is very similar to application allow listing. We have organizations that freak out about application allow listing, and they also equally freak out about internet allow listing. Turns out you don't have to freak out about either one. There are very easy ways to implement internet allow listing and application allow listing in your environment, right? Vulnerability management. How do we approach vulnerability scans to prioritize which vulnerabilities we should be going through. Active Directory hardening, things like Ping Castle, we'll be sharing that. I'm going to probably create a very cool little lab before we get to that section of this class. And then, of course, backup and recovery is present and accounted for as well. And for all of these, we have labs, lots and lots and lots of hands-on, tons of labs going on. I'll get to that here in just a few moments. There are things that we are not covering in this class because it is a count them 2 day course that we are teaching here. The first thing we're not going to cover is introduction to Windows. We're also not going to be covering an introduction to Linux, TCP/IP, even though I'm totally going to rant about the OSI model. It's coming, folks. I'm just warning you. Intro to crypto, intro to security models, the CBK. We're not going to get into the NIST 800 series, data loss prevention, because that crap doesn't work at all. We're not going to be getting into the exploit du jour. The reason why we're not getting into these things is because we cover this in another class called SOC Core Skills. SOC Core Skills is a class that's developing these core security skill technologies in your environment for you personally so that you have the skills to understand these things. Now, that doesn't mean I'm going to ditch you. It doesn't mean that we're not going to go through and cover step by step how to use the different tools that we're covering here. We're absolutely going to do that. So if you're coming in with very little Windows experience, you're going to be fine. If you're coming into this class with very little Linux experience, you're also going to be fine. Everything's going to be okay. It's fine. It's fine. You're going to be fine. It's good and it's wonderful and it's great. Okay. It's going to be okay because I give you step-by-step instructions, but I do encourage, if you're just getting started, to go back into the Intro to SOC Core Skills and learn those topics as well. So as I said, we started tracking the 650 assessments that we do per year. And we started looking at what were all the critical vulnerabilities. These are vulnerabilities that led to a direct exploitation of an environment. A direct exploitation of environment. So at BHIS, we do over 650 assessments per year. I think we're at like 700 assessments now. It's a lot. It's a lot of assessments, trust me. And we started tracking what would have actually stopped us. So if we actually got code execution on an endpoint, what would have stopped us? With the technical control that would have stopped us would have had a good EDR or application allow listing. Once we got access to that environment, we could move laterally and we could exploit the Active Directory environment with Bloodhound, turning on host-based firewalls, or looking at UEBA would have stopped us. So we really tried to focus on just incorporating things in this course that would have stopped an actual attack. We also had to look at it from the IR perspective, looking at organizations actually got compromised and walking backwards from those compromises and trying to look at what would have stopped the attacker in that scenario as well. So it also took a little bit of unlearning, right? Just a little bit, because we do find organizations get compromised by unknown hosts. We do find organizations get compromised by unknown services, but the vast majority of the time, organizations get compromised through spear phishing on a host that is known. Lateral movement to Active Directory to a number of different servers and services. We also see organizations get compromised on a regular basis with actual services that are exposed and accounted for. So yes, we do see organizations get compromised by things they didn't know existed. The best example that I can think of in this is the Colonial Pipeline breach that I was actually outed by Colonial Pipeline. They were like, yeah, we're working with John Strand. Yay. Let everyone know that I'm a thing and I have a company and we work with big incidents. That's like putting a cowbell or a dinner bell on BHIS. But at any rate, that was a company that was compromised through an unknown service, an unknown VPN service that the attackers were able to take advantage of. So I'm using all of this to say, when we created the critical controls, we created the critical controls with a really good starting premise. You can't protect what you don't know you don't have. And we had inventory start there. And it was a fine thing to do. But the reality of that situation is it's probably not the best place to start to try to inventory absolutely everything in your environment before you move off of those controls. It's probably good to put some controls in place first, but absolutely circle back to those controls as well. We're also going to be tying a lot of this class to MITRE because everything has to be tied to the MITRE attack technique matrix. In fact, we have a entire section dedicated to using atomic red team to do MITRE tracking and making sure that with stuff it actually works. I love that. The problem with the OSI model is that it's too modern and is only Unix architecture compliant. Actually, it predates Unix. It was first proposed and started worked on in 1965. That's coming up later. Don't get me derailed. Don't get me derailed. You're going to get me derailed every time. Every time. All right, so let's start with a really fun derailment. Let's talk about the critical controls and why this is so important. So one of the issues that you run into is that there's far too many different frameworks available for computer security. Does anybody, Jen, okay, do we just want to do the OSI thing now just quickly? Because it's going to keep coming up. You're all curious. It's coming up like, yes, it does predate Unix. It does, as a matter of fact. Okay. F it. Here we go. The OSI model is not how computers work. It just isn't. There's no such thing as the 7 layers. Doesn't exist at all. So if you want an article that you all can read, here's an IEEE article called "The Internet That Wasn't." And this right here, just so you know, is why these classes don't relate well for just on demand. I'm putting it in resources as well, so you can read about it. But the OSI, Open Systems Interconnect, basically was created by consensus a long time ago. And what happened is you had an actual model that you were supposed to use for networking protocols and things like that. It was never implemented. It just wasn't. And if you don't, you want to go back and look at some of my other classes, like create a filter that shows me the presentation layer in TCP dump. Create a filter in T-Shark that shows you the presentation layer in every single packet. You're not going to have that exist. There are only 4 layers. The Stevens 4-layer model or the TCP/IP 4-layer model is how computers actually work. Yeah, you need to know OSIs for certification, but if you want to know how the internet works, it's the TCP/IP model. So this is a great article. In fact, even the United States government looked at the OSI model as a separate and unique like standard from TCP/IP, because as early as the 90s, the United States government was still pushing organizations to use the OSI model instead of the TCP/I model. But the TCP/I model, it just works. It's how firewalls work. It's how switches work. It's just how stuff works. Like there is no session layer firewall. There is no presentation layer firewall. All right. And also, when you're looking at the presentation and the application model, those layers, just to give you an example of how broken OSI was, the reason why we have a presentation layer is because there was a German IT company that called their application layer the presentation layer, and everybody else called it the application layer. They got into a huge argument, nerd fight. And their solution was to create 2 separate layers. So the German documentation for their IT infrastructure was still accurate, and then everybody else still had their application layer. So by that consensus and trying to build something around consensus, it just made it stupid. This isn't even a good mental model for how computers work. It doesn't work this way. There are tons of applications that don't work this way at all. Just know that once you get to the application layer, it's the Wild West for that individual application. So this is an excellent article if you want to read it. No, it is not written by me, but it is absolutely just anybody that says OSI is something that we should be using. They don't understand the OSI model. They don't understand like the history of it. So there you go. So let's get back to the slides. Are we done with that? I did that rant, and that's actually the fastest I've ever done that rant, by the way. I'm getting better. So use the TCP/IP 4-layer model. Stop asking people about the OSI model in interview questions, and just stop. Stop. And if you ever get into an interview, you should totally explain the OSI model and then actually go through and tell them it's like, actually, the OSI model is not how things work. It's the TCP/IP 4-layer model. The OSI model was originally created and conceived back in 1975. And there's an excellent IEEE. No, don't ever tell people in an interview they're wrong. Don't do that. That never ends well. But stop the insanity. Stop the cycle of pain moving forward. We can't perpetuate this abuse. All right. So compliance issues. So God, moving from one rant to another rant, right? So compliance issues. The problem that you run into with compliance issues is that there's far too many different frameworks. There's probably 50 heavily used frameworks in computer security. There's an excellent XKCD like cartoon on what was it? Protocols? What was it? It's XKCD. It's not protocols, standards. This one right here. There are 14 competing standards. 14? That's ridiculous. We need to develop a universal standard that covers everyone's use cases. Yes. Situation. There are now 15 competing standards. Ouch. That hits right here. That just hits hard, right? It's like HIPAA, healthcare is like, we're precious snowflakes and we need something specifically for healthcare. And then you have DoD, they're like, we need to have our own standards for classified information. And everybody creates all of these overlapping standards and all these different things, and they're trying to hit like 98% of the exact same things. It's just kind of crazy at that point. And also recommendations get out of date very, very, very quickly. So if I can still find it, I've been having trouble with this lately. So if we look at the green paper, I think this is actually, thank you, NIST. What? Trying to, there we go. See if this is the right one. Nope, it's not. This is for the green initiatives. NIST Green Book. You would think I would just have it downloaded and I would just run it. Let's go to this one. Nope, that's not it. And anyway, I'm not going to spend all time hunting around for it. But basically, the NIST Green Book series says that your passwords need to be 8 characters long. And the reason why your passwords need to be 8 characters long is because the Russians could brute force at 1 million password attempts per day, every possible password attempt within 30 days. So therefore, your passwords need to be 8 characters long, and you need to change them once every 60 days. Now, the problem with all of that is if you were following the exact same model that they talked about when the NIST Green Book was released, which was 1985, you would have to change your password once every 0.5 seconds today. So that idea of an 8-character password continued to evolve over time. I'm kidding. It didn't evolve at all. Ton of standards just continued to use the 8-character password standard because it's what the previous standard said. And they were like, someone really smart must have come up with that. And then they did another 8-character password standard because someone really smart must have came up with that. And we had these bad password complexity standards that carried forth. In fact, PCI just recently They just recently updated their password complexity standard to 12 characters, which is still bad. It's better than what it was, but it's 12 freaking characters, which is stupid. The password policy for PCI up until last year was only 7 characters. So like literally PCI looked at password complexity and they're like, whoa, this 1985 standard, when we had Teddy Ruxpin's boomboxes, Back to the Future, got to pump the brakes on that one. It's a little bit too rigorous for companies all the way up until like 2024, 2023. Then they just updated it to 12, which is not great either. So you see these bad ideas continue to move forward again and again and again. Then you get into a problem where people just focus on meeting the minimum. What is the absolute minimum that we have to do to be successful in our security framework? So Audit Scripts has changed all this. I have to update the slides here, but I want to show you what actually does exist here. And I'm going to share this in the chat as well. So CIS has excellent mapping and compliance where you can map to a PCI DSS, map to NIST and FISMA, HIPAA, GDPR, which is weird because GDPR isn't a compliance framework. And then also mapping, and a lot of these states are actually implementing the critical controls. So you have the ability now to get in compliance with the critical controls and have the ability to then map those controls automatically to other frameworks. And they have a really cool tool called the Compliance Navigator or the Controls Navigator. I'm going to share this with you as well. Here we go. There we are. And for each one of these safeguards, which you can download as a spreadsheet, by the way, you can look at what are the different frameworks and other audit standards that it maps to. So we have the AICPA SOC 2, CISA, Cloud Security Alliance, Cybersecurity Maturity Model Certification, Digital Resilience Act. We have FFEIC, HIPAA, more HIPAA stuff, ISACA, just all of these standards. So what happens is now you can map to the critical controls. And then from the critical controls, you can crosswalk the mapping to these other standards. And like I said, a lot of states are implementing their standards, the CIS standards, as the standards for that state. Now, why is that important? Because if you're mapping to the critical controls in many organizations today, I think there's something like 16 or 19 states right now that indemnify you if you're breached from having penalties brought against you, which I think is a good thing. If you're doing a reasonableness test to say whether or not we're meeting a reasonable level of security, this is a great place to start. You can always be sued, but from the government perspective, they won't. So this is the reasonable security guide from the Center for Internet Security. There we go. So you can actually get that. And a lot of the stuff that we work through in this class is also covered in this guide as well. I also have some things that go a little bit further because it's easy to implement them, and I'll explain those differences here as we progress. All right, so lots and lots and lots of really cool stuff. Now, also, when we're looking at this class, as I said, I'm going to be mapping what we're talking about and how it breaks down different categories of the MITRE attack technique matrix. So if I go back to the MITRE attack technique matrix, here we go. If I go to the MITRE framework, we go to the enterprise matrix like so. I'm not going to go through every single one of these categories, like these individual ones, like inter-process communication. Adversaries may abuse inter-process communication share mechanisms to communicate across shared data, communicate with each other, and synchronize. I'm not going to do that. Instead, we're going to talk about how you can implement strategies in your organization that will automatically take care of entire categories of attacks. For example, if you go through and you look at lateral movement, we have 9 techniques. We have exploitation of remote services, internal spear phishing, lateral file transfer, remote service hijacking, remote services media. You could shut down almost all of these by enabling host-based firewalls so your workstations can't talk to each other. So why spend a lot of time focusing on how we deal with a technique, where instead we can sit down and we can come up with how we deal with a category class of techniques. If we're looking at command and control, we can shut down command and control by doing appropriate internet allow listing. We can also shut down command and control and exfiltration by having good egress traffic analysis with tools like Rita and AC Hunter. So we're going to be showing this and we're going to be walking through this in a lot more detail and breaking down these things based on categories and classes and how to shut them down as well. All right, so let's get started with the first one. Try to get to our first lab. Before we get rolling with this, what do you think are the main problems that people run into whenever they're looking at application allow listing? Like, what do you think are the biggest concerns that exist? Like, if we're looking at application allow listing, complexity, right? Complexity is right up there. What are some other ones people come up? Too time consuming, possibly breaking things in production, right? You might be worrying about that. So much to do that it just becomes overwhelming. In where do you even start, right? And then things changing, you deal with updates, stuff like that. So how do we deal with application allow listing in such a way that it's effective for us to deal with application allow listing? So let's talk about straight up deny lists and why they fail. Right? Traditional antivirus products work on a deny list perspective. All right. And Marcus Random had this great article a number of years ago that was the 6 dumbest ideas in computer security. So let's go ahead and do that. Doing that. There we go. Here we go. 6 dumbest ideas in computer security. You guys can look at that. And he has like default permit, but the big one that he talks about is enumerating badness. Now, this is something that he wrote back in the 90s. Okay. And the whole idea about this was, what do we do when we're trying to enumerate evil and the amount of evil is growing exponentially as far as what's being allowed into our environment? And this applied to firewalls, this applied to IP addresses, this applied to domains, and it also applied to traditional antivirus products that were merely looking at hashes of different files and programs to stop them, right? But the thing is, your like human brain with UG and thug absolutely resonates with denialists. Like, as human beings, this makes sense to us. It absolutely does make sense to us. You see, as human beings, we look at things as things to avoid. For example, I use this narrative quite a bit. Let's say that you have two cavemen walking down a path, and it totally was two dudes that do this. Just stick with me. And we'll just call them UG and thug, right? So UG and thug are walking down the path, and UG sees a mushroom and tells thug, eat the mushroom. And Thug is like, I'm not eating that mushroom, dude. Ug's like, you totally got to eat the mushroom, Thug. And Thug is like, I'm not going to eat this mushroom. And finally, Ugg says, dude, I double dog dare you to eat this mushroom. At that point, Thug is like, man, it's a double dog dare. I got to eat that mushroom. So he eats the mushroom and he dies horribly, like frothing at the mouth, blood coming out of his nose and his eyes and his ears. And he's screaming, what? And just like that, Thug was gone. So from that point forth, Ugg and the rest of the village had a song. And I'm translating it from Caveman, so I'm paraphrasing a little bit, but it's like, Thug the idiot ate the mushroom. The mushroom was green with these yellow spots, and we don't eat the thug mushroom, which is green with these yellow spots, because we'll die horribly with blood coming out of our butt. It doesn't roll off the tongue as well as it does in the original Caveman. It's really romantic in the original Caveman. But the point is, human beings were trained to denialist. Like from the beginning of time, we absolutely, oh, you need me to turn it back down? Oh my God, let's turn that back. How's that, Ryan? Is that better? We getting a little bit less clipping? This is a check of the microphone. We're going to be checking on the clipping. There we go. So the point is, human beings look at risk in terms of what we should avoid. Don't eat that mushroom. Don't party with juggalos. I don't know. You might be a juggalo. I apologize. I shouldn't pick on juggalos. I really, really shouldn't. I got to do something. No, I didn't swear. Did I swear? I haven't sworn yet, but I did rip on juggalos. I did. I did. So I feel bad about that. I know we have some Juggalo here in the family, and I'm going to say something good about Juggalos. All right, here we go. Insane Clown Posse is amazing. Insane Clown Posse, I don't much care for their music. It's a personal taste thing. If you do, that's fine. But Insane Clown Posse built their own effing scene, which we're going to be talking about a little bit later as it comes to Henry Rollins. They started up their own record label, and they did all of their self-promotion, and they did all of their self-publishing. And them as artists are actually wealthier than the vast majority of big artists that you see today because they created their own scene. So there you go. There's some really good things about Insane Clown Posse and the juggalos that are out there. All right, let's go back to it. But you have these things that you should avoid, right? You should avoid walking across the street in the middle of traffic. You should avoid snuggling with like polar bears. Nothing wrong with polar bears, just polar bears are going to do what polar bears do, and that is eat you. All right? Now all of a sudden, you try to apply that mental model of trying to avoid things today. Because if we go back to the UG and thug model, if we're looking at malware on computers, malware is constantly evolving. The threats are constantly evolving. So today it might be a mushroom. Tomorrow it might be a sizzling, tasty filet mignon. Because it's actively changing. So human beings are not built to identify rapidly evolving risks. And you can see this today, how we relate to the internet. A bunch of people consume garbage on the internet. Like, I'm just going to blame TikTok and Twitter and Facebook. I'm just going to blame the internet. Let's just blame the internet. And people see things on the internet that they want to believe, and it keeps feeding it to them. But we aren't adapted to have a very rapid skepticism of our surroundings. We just aren't wired that way, right? So denialists don't work, even though denialists get right into the brain of what we're actually thinking about. So denialists have not been working since like 99, and Marcus Ranum in his article. So when we're looking at post-exploitation, if we're working with just a standard denialist methodology, this gets us into the sacred cash cow tipping series that we did at Black Hills Information Security, where every year we would get together and we bypass all the major antivirus engines in a day, and then we'd share how we did that. You can see those videos out there. They were awesome. They were great, great, great time. The point is, it usually takes an attacker moments to bypass most of the security controls that exist. Almost any of the techniques that you can try can work if applied in a creative fashion. So there's our 6 dumbest ideas in computer security graph. So here's a stupid example, just a dumb one, ghostwriting. This still works if you can do it correctly. Now, let me explain how this actually works and why we don't see a lot of attackers do it today. Spoiler, it involves assembly. All right. So what happens is whenever you're looking at a computer program and you disassemble said computer program, there's a lot of sections that are blocks of code. Those blocks of code can represent a variety of different things, like the getS function, fgets. You can also see string copy functions, memcopy functions, Doug Leah implementations of memory management. You have these different functions that can be implemented from the operating system and from the various coding modules that it's incorporating. And it literally looks like blocks. You can see that one block calls another block, which calls another block, which calls another block. And a lot of the advanced EDR products, when these products are running, they will look at how that program is executing vis-a-vis the kernel to look for potentially malicious hooks and how it's accessing the kernel and what it does. But it requires it to understand what the modules are actually doing when it invokes the kernel itself. So we have lots of blocks of code that do stuff. And you can identify those blocks of codes with things like the procedure preamble. You can identify how that code is laid out rationally with a debugger. All right. So what we can do is we can create an executable that's malware, convert it into an assembly file, edit that raw assembly file directly and convert it back to an executable. Does that sound hard? Does. Totally not hard. Like barely an inconvenience. Let me show you how. So Metasploit has a lot of different modules. One of those modules is one called MetaASM. It allows you to do assembly modification and allows you to disassemble a raw executable into its like relevant assembly. So you take that compiled binary and you can convert it into the assembly. Once again, totally not difficult. Stick with me. You can do it and it makes you look like an absolute badass. So you take your payload, you can use MSF Venom or MSF payload and kick out the raw binary. Just the raw binary executable. Then you use MetaASM to convert it to an assembly file. Now, don't freak out right now, because if you're looking at this, you got like CLD, FC, call sub 8, channel, push AD. We're moving ESP into EBP. We're XORing EDX to EDX. We're moving FS to EDX, and we have offsets and all these things. And it's just like, I'm lost. Don't be lost. Instead, I want you to focus on this XOR. Do you see that XOR from itself to itself? What is XOR? Anybody know? What is XOR? If I XOR a value with another value, what am I doing with that value? By the way, don't panic. This is a lot easier than you think it is. Just you're making it harder in your head than it should be. But just what is XOR? It's an exclusive OR, right? Simple. Chad's got 0 plus 1 equals 1, 1 plus 0 equals 1, 0 plus 0 equals 0, and 1 plus 1 equals 0. Now, he's absolutely correct, or they're absolutely correct. Absolutely. But that might be a little bit difficult. Let's go through it, Chad, just so people can see. So I'm going to open up text edit, and we are going to open up a new version here, and I'm going to ambignify this. Oh, there we got a little circuit diagram of XORing. Yeah, there we go. Looking at logic gates and XORing. See, it's easy, right? Okay, so what we're going to do is this. Oops, I did not want to do that. There we go. All right, so here's the deal. If the top and the bottom number are equal to each other, it's a 0. If they are different, it is a 1. So I go through and I do 0, 0. Really confusing people. We go 0, 0, 0, 1, 1, 0, 1, 1. Now, let me explain why we do it this way. So we have the top and the bottom. We're doing a comparison between those two strings. So if I have two strings that are equal to each other, I can do that same type of mathematics and I'm going to get 0. That means they are equal to each other. The XOR value is zeroed. If there's anything different between those two, then the value is always going to be 1. Okay? So up here, they're the same, the value is 0. They're the same, the value is 0. They're the same, value is 0. So let's use an example. Let's say that you're putting in a password, right? And I'm doing a comparison of that password. Your computer lives in ones and zeros. One of the ways that you can check to do a comparison with the password that was entered with the password on file is to do an exclusive OR. If the passwords are equal to each other, the value will be 0. If there's anything different, it will not be 0. And then we know that they are unequal to each other. Does that make sense? How did that go? Was that hard, everybody? It's a way of doing comparisons mathematically with, there we go. Awesome. Very good. Awesome. So when we're XORing a value, let's say a register value from itself to itself, what is it always going to be? So if we have a registry value and we're XORing it from itself to itself, it's always going to end up with 0. All right? So what you can do is literally anything you want before that register. You can do anything you want to that register. You can add 1 to ESP, subtract 4 to ESP. You can do all kinds of crazy things because at the end of that string, you're going to clear out that register by XORing itself from itself to itself. So at the end, it's always 0. So what we can do is add a bunch of garbage before that. We can push, we can pop, we can add 1, we can -1, we can add all kinds of values. The more you add, the better. And it just adds all kinds of garbage. And then at the end, a lot of AV engines, just like, I don't know what this executable is because they can't look at the blocks of code. Because they can't understand it, because they're looking for a specific string and block pattern matching within that code itself. This is a fun trick. You can do this trick to impress your pets. You can do this to impress your friends. I recommend pulling this out at Thanksgiving and Christmas to impress your family, because everyone's going to look around and just basically be like, yeah, that person's really smart. That's a person that I want to call to have them come over and work on my printer, right? Yeah, that's what you're looking for. There you go. Then you finalize. Once you take that ASM, you can take Metasploit and use peen code, and you can output it to an executable of your choice. There you go. Start the multi-handler, run it, and get compromised. Now, the other way that we can get around a lot of traditional antivirus products is we can use LOL bins. This is where we're using built-in executables post-exploitation on that computer system to move laterally. This is where we're using the actual operating system against itself. Yes, suppressing pattern matching. So if we're sitting on a corner and we're looking for only blue cars, like let's do a Dishwalla reference, because tell me all your thoughts on God. So if we're sitting on a street corner, we're watching for blue cars, all we need to do is make sure our car is not blue. Is this how polymorphic viruses evade AV? Yes, it is one of the ways that polymorphic viruses can bypass AV. But here's the really weird thing. It's not the only one. There's like a lot, a lot. For example, any code, I can run it through and I can make it so every add function becomes a subtract function. Because if you subtract a negative value from itself, it's the same as adding. So you subtract a negative value instead of adding values. We can do that. So there's a ton of different ways to do this. Now, does it work all the time? Hell no. Sometimes you have to choose specific areas and do it in just the right place. There's also other areas in assembly where you can mess with the executable as well. But the point is, there's a number of ways to get around AV engines, right? I can also use LO bins, like I said, where we can sit down and we can start using the built-in binaries in the Windows computer system against that EDR. Because there's tons of things like certutil, run DLL32. We can use PowerShell downloaded from the Microsoft Store. These things work crazy well. So the point of all of this is what worked in the past few slides probably isn't going to work into the future. We're trying to dodge AV. There is a lot of dynamic properties that you have to learn, you have to work through, but they all start with some very fundamental basic things. Using different libraries in a way that wasn't intended, using different libraries in a way that the AV engine is not hooked into the operating system. You have to be flexible, you have to be creative when you're creating your payloads. And the goal of this isn't like, here's how you bypass AV. We have other classes for that. May I recommend Geoff Thayer's class on creating implants? Check that one out as well. Or you could just hire Geoff. That's what I did. I just hired Geoff to bypass AV engines, and that works well. Okay, so you have a lot of different things and a lot of ways to get around AV. So what does that leave us with? Well, we can do encoding and obfuscation. As I said, we can also use modules like Shikata Ganai, which is Japanese for there's nothing that can be done about it. And Shikata Ganai is actually a polymorphic encoder. If you encode the same executable multiple times, the binary that comes out the other side will be different every single time. All right. So there's a number of different ways that you can make that work. There's also tools that automate this process. So like we have someone that sometimes brings up, I've been doing this for a few months now and I feel like I know nothing. And this stuff all seems like gibberish to me. That's fine. It seems like gibberish to most people. That's okay, because there's tools that'll automatically do this. Dave Kennedy and the folks at ATT&CK have created a tool called Unicorn that automatically does a variety of different encoding examples to do that type of output kick that you don't even have to know how it's doing it. It's just giving you an idea of some examples. And the other thing is Dave and his team tend to keep this up to date with some of the most current techniques for bypassing EDR products that are out there today. Lots of tools, lots of techniques, tons of different ways post-exploitation where we can use these techniques against the defenders as well. So this brings us to application allow listing. So instead of trying to play the game, we're going to try to enumerate badness and all the different types of badness. Everything comes down to that initial code execution. So I want you to spend a couple of seconds. Just spend a couple of seconds and let's jot down what are some directories that we think malware would execute from. So if I'm spear phishing a user, where do you think the initial malware would execute from? Just spend a few moments. Let's noodle on that. Where would it run? I'm a user. I'm surfing the internet. You're phishing me. What about like downloads, right? Downloads, absolutely. The download directory, temp directories for like internet folders, the home directory for users, documents, possibly even the desktop. So this gets into a question that we're kind of getting into. Why do we allow code to execute from those directories? Like, do we need to have executables running in downloads? Do we need to have executables running in like the desktop? Documents? Do they need to be there and executing code? That seems a bit strange. So one of the things we could do is we can find directories where programs are allowed to execute from. So let's spend a couple of moments, let's think about it and jot down where should programs actually execute? Where should we see programs actually executing from? On Linux computer systems, we see it in the bin directory. On Windows computer systems, we'd see them in the program files x86, the Windows System 32 directories, right? So what we can do is we can set it up so programs are only allowed to execute from those specific directories and no place else for specific users on that system. Now, if you want to, if you're dealing with highly secured environments and highly secured systems, you could also do the allow listing approach by hash and by manufacturer of the program. And I'm going to go through and I'm going to show you how this works here in just a little bit with our lab that we're going to be working with. But you can actually do it at that level of detail. I would recommend doing it at that level of detail for things like kiosk systems. Like I said, let's say a teller at a bank, right? Somebody that's working at a hotel that's, just taking and checking people in. You really have super limited applications that should be executing on those particular workstations that are out there. Now, this sounds easy, but it's very difficult to implement fully in an environment. Another way that you can do this is you can establish custom rules for so certain publishers are allowed to execute on your system. For example, let's say that something from Oracle, God help us all, has to execute in the downloads directory for every user in your environment. You have this app that's by a vendor, has to run from the downloads directory. Otherwise, hellfire, brimstone, dogs and cats living together, absolute pandemonium if this doesn't execute from the downloads or the desktop or the documents directory. Not a problem, because you can take a sample executable and in Applocker, you can say, create a rule for this vendor, for the specific digital certificate from this vendor, so that signature and that vendor is allowed to execute from anywhere on that computer system. This is great. This is very, very effective for you to be able to kind of open it up, and you don't have to get super crazy with allowing your rules for every executable everywhere in your environment as well. A quick warning though, a lot of vendors don't sign every dynamic link library and every single executable. So you do have to be careful. You have to watch out. You need to test it thoroughly before loading it into production. So we're gonna have a lab here in a moment. We're gonna look at Applocker. Applocker can create allow listing based on the path, the hash, the cert, and the vendor. It's also fairly easy to configure and push out via group policy. And I have a wonderful little link that I've provided here for you. You go in to your security policy and you say, we're going to do the local security policy. We're going to set application control policies. Then we're going to enable the rules. The rules are executables, Windows installer rules, script rules, and package app rules. These are the main ways that we can see programs execute on a Windows computer system. We go into each one of those and we right click and we do create the default rules. We do not do automatically generate rules. This will generate thousands and thousands of rules for not thousands, probably a few hundred, for all of the different executables on that computer system. We create those default rules in the environment. All right. So you create the rules, and the default rules are based on path. It says it allows programs to execute from the program files, allows the files to execute from the Windows directory, and allows the administrator account to execute any file of their choosing. Turns out this will shut down something like 98% of the drive-by downloads that hit your environment today. So it's a very powerful technique for you to be able to use to be able to stop that initial attack. Because all of the stuff that I talked about earlier by, using LOL bins or using a bunch of different encodings and obfuscations to try to execute your code, that all tends to work, but it still requires initial code execution from a very limited number of places, like documents, downloads, desktops, temp folders, things like that. So this says that only programs are allowed to execute in the Windows directory, in the program files, and sometimes program files x86 directory. And then that's going to shut down like a huge percentage of the drive-by downloads and exploits that hit your environment as well. The final steps are we have to enable the application identity service on your computer system, and then it's ready to rock and roll. So now we have our first lab of the class. All right. So we've given you the Cloud Lab instructions. If you haven't seen this yet, it's in the Discord server. It's in resources. That's where all of our resources exist. And this will set up your lab environment in MetaCTF as well. So once you have this set up in MetaCTF, you can do View Manage Lab. And then once you're in, you want to select Start Lab. Okay? You're going to select Start Lab. And it takes about 150 seconds for it to start the lab up. and I'll show you how to access it. Don't start each virtual machine. Start them both with start all virtual machines. And at the end of the lab, do me a favor and select destroy lab. That will kill your VMs completely and you won't be charged for them anymore on that as well. Now, the labs that we're using are here in this GitHub repository in HK, and a number of people have shared those links out. You can see those links in the resources section. You can pull those down, a bunch of places where you can get those. And we're going to be doing the Applocker lab. Let me go back here. Let's go to intra-class files, navigation, and we're going to go down to intro to security, and we're going to start with Applocker. Now, this particular lab, the goal of this is to show you how we can create and execute malware on your computer system. All right. You're going to go through and you're going to disable AV. Now, I know that this is incredibly lame, the idea of disabling AV. This class's goal is not to show you how to get around antivirus, although convincing someone to disable their antivirus is a really effective way to disable antivirus. It's not really practical for most exploitation techniques. So we want to disable the antivirus on the system. And I'll come back to that here in a second. We're also going to disable the firewall, which actually is pretty close to the way most most Active Directory systems exist. Most of your computer systems, when they're in a coffee shop, they're like, yeah, putting up a firewall. I trust none of you all. Like, it's a bunch of hippies. I think that person's over there with a MacBook, like Air, writing on a novel or something, feeling really uncomfortable about everything in this coffee shop. Your computer doesn't trust it. You shouldn't trust it either. But whenever your computer goes back into the corporate environment or Active Directory environment, it's like, I know this network, shuts off its firewall, right? It just shuts the firewall down. It's kind of like, have you ever seen the show F is for Family? Anyone seen that one? Yeah, the dad in this show, just walks in the house and takes off his pants to relax and just walks around. That's too much. That's the way your computers are, right? Like, they literally just shut off their firewalls, crack open a beer, everything's good here. It's fine. It's fine. That's how your systems are. Then we're going to set the administrator password to 1234. Once again, don't do that. Although you would be incredibly surprised, shocked, and or amazed how often we see people use the password of administrator password 12345. It happens. See, it's not 0. If it's not 0, it's too damn high. There we go. It's just the way it is. Then you're going to get your Windows IP address. You're going to open up a Kali instance on your system. You're going to become root, and then you're going to mount your Linux system over to your Windows computer system. Right here, I have this highlighted. Just stop. I know if you're passively listening, you're not really listening. You need to stop, hesitate, and listen, or collaborate. We're going to collaborate and listen. We're not going to hesitate because that's wrong. That's how I used to sing that song in the 80s. But you see that where I have it highlighted, your IP address, where it says your IP address and it has the brackets, you're going to replace all of that with your Windows computer system's IP address. This is the single biggest mistake that people make in this class. You put in your Windows IP addresses, not in between the brackets. It's a variable, so the brackets have to be replaced. All right. So everyone's got that. We're ready. You're still going to have someone who's not listening. And I feel bad for that person. I guarantee you, we got 200 people live on Zoom. I don't know how many people we have on YouTube, but somebody isn't paying attention right now, and they're going to have to put their IP address in there with the brackets, and they're going to say, oh, it's broken for me. It didn't work. It didn't work. And everybody's going to be like, dude, John told you. John told you. You have to replace what's in the back brackets. All right. Don't do the sheeple thing. We're going to mount that share as our administrator account. Then we're going to CD into that directory. We're going to get our Linux IP address, and then we're going to create some malware. Once again, where it says your Linux IP address, you're going to replace all of that, including the brackets, with your Linux IP address up above. Then we're going to start MSF console quiet. We're going to use the exploit multi-handler. I'll explain what all of this is when we walk through the lab. We're going to set the payload to Windows Meterpreter reverse TCP. Going to set the LOs to be your Linux IP address. Then we're going to type exploit. Nothing is going to happen. Once again, this happens all the time with students. They're sitting down, they're not listening, and then they get to this point and they're like, I exploited the system and nothing happened. And I'm telling you right now, people that aren't paying attention, nothing's going to happen. Nothing. You're going to move on to the next step. You're going to CD into the top level directory and you're going to execute the malware, trustme.exe. You should have a interpreter session. Now we're going to stop this from happening. How do we stop that code execution? You're going to go to local security policy. You're going to go to application control policies, Applocker. You're going to create executable rules, Windows installer rules, script rules, package app rules. You're going to right click in this big white area. You're going to click the default rules. You're going to do that for executable rules, Windows installer rules, and the script rules. Then you're going to go back and configure rule enforcement on Applocker. Then you're going to start the application identity service. Then you're going to push the group policy with GP update forced. Then you're going to CD into the intro labs with a command prompt, and you're going to do run as user whitelist the netcat command. The user password is ADHD, and it's going to attempt to run it, and you're going to get a program blocked by group policy. Now, with this lab, as I mentioned, I walked through it quickly at the beginning. Then we're going to spend 25 minutes. You all are going to work on this lab together. Actually, let's put 30 on because we got break in here. So we're going to spend 30 minutes on this lab. It's about how long as it should take. And then you can watch me walk through it step by step by step with detailed explanations. So with that, let's jump straight into the lab, everybody. If you need anything, hit us up in tech support. That's what we're here for. It's been kind of busy for a long time. Really just crazy stuff going on here. Yep, and I recommend destroying the lab once the lab is finished. All right, so I started up my lab. It's all running. Now, to connect into the lab, you connect via the Windows system via RDP. There we go. It's going to open up Guacamole. There we go. And then we can just get started. Just doing some simple little copy and paste stuff. Works simple. So the first thing we're going to do is it says open up a PowerShell terminal. We have that highlighted over there. So I'm going to go ahead and allow systems to connect to me. I'm going to open up PowerShell. And then I'm going to copy this whole command. Now, this command disables the antivirus on your Windows computer system. So the reason why that's important is, once again, we are not trying to bypass AV. The goal of this lab is to show you how we can shut down a tremendous amount of the different attacks that are running on your system as well. All right, so let's go ahead. We're going to disable that firewall because you saw that little blue box that popped up on my system on the right-hand side over here. That turns on the firewall because it doesn't recognize the network as a legit safe network, I guess. So it pops up. So we want to make sure that we can allow those systems to connect to us. And the way that we make sure of that is making sure that that firewall is actively disabled on the system. Then I'm going to set the password net user administrator to password 1234. And now my Windows system is almost ready to go. I'm going to do IP config here. Do that. Copy and paste. There we go. And I'm going to set this window off to the side right now. Just kind of get it out of the way because I'm going to open up my Kali instance and I'll need that IP address here in just a couple of seconds. Now, when Kali opens, we're going to get this error. There's a little black magic that's going on in the background with MetaCTF and the lab environments that is basically dynamically creating configs so your Kali box knows where, or sorry, your Windows box knows where your Kali box is. So you have to hit accept. Then I'm going to change my settings. This wasn't part of your instructions. I'm going to change my font. I'm going to make my font bigger on this system. I'm going to change it to 18 and bold, yet tacky and unrefined, much like your instructor. All right, so we got that. That looks good. Make that so you all can see it. Then we're going to become root in our Kali box because we're doing root things. Now we're going to mount that Windows share. And I have to do that thing where we need to change out the IP address right here to be the IP address of the Windows computer system. So I'm going to delete that whole mess and I'm going to put in 10.10.252.58, like that. Now I've got that share mounted. So now I'm going to cd into mount Windows share. There we go. And now we're going to run the command to get our Linux IP address. Got that ifconfig ready to go. And now we're going to create our malware. And I'm going to spend a little bit more time with this command. I'm going to change my IP address to be my Linux IP address, which is 10.10.201.90. And that'll become really important here in a couple of seconds. All right, so we have MSF Venom. We have A is the architecture. That means like, what is the architecture? Like PowerPC, 64-bit. We're running an x86, a 32-bit payload, all right? Then we're gonna say the platform is a Windows system. And then the payload is going to be Windows, Meterpreter, Reverse TCP. Now, the reason why we're choosing Windows, Meterpreter, Reverse TCP is because whenever the system gets compromised, we want the system to connect back to us. So we're going to have to give in our Linux IP address, because when that malware runs, I can't connect to it. It needs to connect back to me. And the reason why it needs to connect back to me is because if somebody's running a firewall or any type of router in an environment, I can't connect to that system directly from the internet. I need it to make that connection, that reverse connection back to me as well. So we put in the Linux IP address, which is 10.10.201.90. We're setting the L port to 4444. The output file format is an executable, and the actual file that we're sharing it out to is Windows share trustme.exe. So we're literally creating the malware and uploading it directly to the Windows C drive. And I'll show you what it looks like when it gets there in just a couple of seconds. But right now you can see I'm currently in mount Windows share. All right, no coder specified, outputting raw payload size is 554 bytes. The total file is much, much, much larger. And there's a reason for that we'll get to a little bit later when we get to sysmon and logging. But the full file size is 73,802 bytes, and it shared it out into Windows share trustme.exe. So if I do ls at the C drive of that system, you can see trustme.exe is present on the remotely mounted Windows computer system on this computer. So next, I'm going to start MSF console. We're going to start it up in quiet mode on our Linux computer system. And the quiet is, I don't want it to display all of the banners. Metasploit starts up with these banners that are kind of funny. A couple of them say you access denied, access denied, access denied. You didn't say the magic word, access denied. Or they'll say error, kernel panic. And when people see that and they're just getting started, they think that something bad has happened, and it's just the banner. So I suppress that banner with the -Q. Next, we're going to use exploit multi-handler once Metasploit gets started. Now, Metasploit starting up takes a few moments. It takes a hot minute or two for it to get running all of the way, but now it's running just fine. The reason why is it's a very large Ruby environment. There's a lot going on in the Metasploit project. So we're going to use exploit multi-handler. In Metasploit, you have categories broken down as exploit is just the category. Exploit of post, or sorry, instead of exploit, you have post, you have scanning modules, you have all these things. So we're choosing exploit. We're then choosing multi. That means works for multiple operating systems. And then we're specifying the handler. So it's going to handle connections coming in. Now, the specific connection it's going to be looking for is the Meterpreter Reverse TCP. All right, it's going to be Meterpreter Reverse TCP. Next, we're going to set up the environmental variable of our L host is going to be our Linux IP address. So our Linux IP address is 10.10.201.90. We're going to put that in as the variable. And then we're going to type exploit. And then nothing's going to happen. It's just going to pop up and it's going to stay starting reverse handler on 0.0.0 port 4444 here in just a couple of seconds. That means that Metasploit is now set up and it's ready to receive those reverse connections coming in on port 4444. So now let's give it something to chew on. Now we're going to start our malware, right? So now I'm going to cd into the top level directory, and then I'm going to run trustme.exe. Now you can see the malware is connected, and now I have a interpreter session locked and loaded and ready to go on this system. So it's all set up and running. Now that's what we want to stop. Okay, we don't want this. So how do we prevent this from actually happening? Well, it turns out we can go through and we can edit our local security policy. Local security policy. So we can restrict which directories programs are allowed to execute from, right? So I can go to application control policies, go into Applocker. Let me zoom in so you can see this. You can see we have executable rules, Windows installer rules, script rules, and package rules. If I select any one of these, it's blank. That's because for most of these rules, there are no restrictions, especially for executables. So I can right click and I can do create default rules, and it creates the rules based on path. So it says all files in the programs folder, all files in the Windows folder, and anything that is executed by administrator. So I want to create those exact same rules for all of these. And now I want to configure rule enforcement. So we need to make sure they're configured and it is enforcing the rules. We click OK. So we have that. Make sure I'm not skipping any instructions here, right? So we went through, went into Applocker. We created the default rules for each of our categories of executables. We have this is configured and it's already set up to enforce rules on our system. So far, so good, right? So if we go through configure rule enforcement, enforce, configured, click OK, but it is not actually on right now. To get it to where it's on, I have to enable the application identity service. So I'm going to do services. Takes a moment for it to pop up. We're going to go to application identity and we're going to start it. There we go. Now we need to do GP update space /force to force the group policy setting on this system that we just made with group policy. All right. And there we go. There we are. So now we're going to show you what happens whenever somebody tries to run something that's not an administrator. I can like run trustme.exe again, and it's going to allow it to execute, and I'm going to get a second interpreter session on my system. You'll see another one that pops up here. Now, I don't want that to happen. So now I'm an administrator. As you can see, I am administrator, and my group policy will allow me to execute anything because I am an administrator. However, if I want to run something like netcat, I can cd into intro labs like that. And then I can try to execute something as a different user on this system. So we're going to do run as user whitelist. We're going to try to execute netcat. It's going to ask for the password. We put in ADHD like so. And now we're getting an error. This program is blocked by group policy. For more information, contact your system's administrator. All right. So that is really a powerful way to shut down that kind of rogue execution that happens so often on computer systems, because so much of that execution originates in the downloads, in the documents file, in temporary files, on desktop. So this will make it so programs can only execute from a specific directory. Now, you may have people that'll say, well, all I need to do is get it in the Windows directory. That's true. They may say, all I need to do is get it into program files. That's true as well. But remember, we're talking about shutting down the initial exploit. And that initial exploit on Windows computer systems is usually going to be in those user directories. So let's say hypothetically, you have an application that you have to run on a computer system. So I'm going to go back into local security policy. And I'm going to show you how you can do some fine grain, super cool stuff with that. So we're going to go back into Applocker, and I'm going to go into the executable rules here. There we go. and I can create a new rule. Now, when you're creating these new rules, there's a bunch of really cool things that you can do with this where you can get really granular. So I can say this rule applies to everyone on the computer system. All right, sounds good. I can now choose how am I going to set up the rule condition. I can do it by file hash. I can do it by path, which we already have the defaults by path, or this one by publisher. So let's say that I have a file on my computer system that is from a publisher that I want to be able to execute. All right, I want to be able to set this up. I can actually say I will allow anything from this specific publisher to execute. So I'm going to browse for the reference file, which I just think is awesome. I'll go to desktop. Let's go to, oh no. Let's go to program files. C. Let's go. I might be able to do it. Let's do program files. Let's do PuTTY. All right. Because the problem with PuTTY is a bunch of people run PuTTY from their desktop. And I don't want to just unilaterally allow execution from the PuTTY or from the desktop. I could create that rule and it would allow everything to execute from the desktop, but it's literally PuTTY. PuTTY everywhere, from downloads, from the desktop. I run it from the desktop. A lot of people run it from the desktop. I want to create a rule that allows PuTTY to execute. So if you look at this, you can see that the publisher is Simon Thatham, Cambridge. We have all the information about the publisher of that executable. The product name is PuTTY Suite. The file name is PuTTY, and I can even set it to the version. So I would usually set it to this, where the publisher, the product name, and the file name is allowed to execute on this computer system. So you can set up that granularity. Is there a way to create this local policy on multiple machines? Yes. If you go back to that link that I had earlier in the slides, it shows you how to push out group policy for Applocker across all of your systems. So anything you do here can be created as a group policy that can then be enforced to a bunch of different systems. We also have good questions, like, could you still execute shortcuts from the desktop to point to the program files? Yeah, you could absolutely set those types of things up. So there's a number of ways to make this work. And you don't have to make it as we're going to allow everything to execute from the desktop. So we click next. You can create exceptions, create next, and then I now have that rule. As soon as I hit create, I now have a PuTTY rule that I've created on my computer system. So this gives you a tremendous amount of power. You can easily add in more rules. You can add in more directories. You can add in more executables that are required that'll allow you to do this. So very cool stuff. All right, so I'm going to close that out. And I'm not even going to mess with this. I'm going to go back to MetaCTF and I'm going to destroy the lab. Let me show you what happens if you don't destroy the lab, especially with what we just did. If you choose to let that lab continue to run, the problem is we changed the local administrator password. So when Guacamole tries to log in, it fails. So to get around that, hit destroy lab and it'll stop charging you credits. It'll kill the entire VMs. And when you start up the next time, you start with a pristine lab with no issues. So if you see anybody that has an error, could not authenticate with Guacamole, if you all could help me out in letting people know, they need to destroy their lab and they need to recreate it. It's just a good habit to get into. All right. All right, so let's go ahead and let's talk about password controls. And we get into some fun password labs here in just a little bit with it as well. So let's jump in. So password spring. Oh my God. There's a lot of things that are going on in the world of computer security. And I think that some of them are really great. It seems like for the longest time, the way that they were trying to deal with password security issues was to make passwords longer and longer and longer, trying to get away from dictionary words, making them 28 characters. Can't use the same password you used the past 50 times. Must be a completely randomized passwords. It's bad. It's just bad. So you see one of two things happening. A lot of organizations will reduce password requirements because it's too onerous and too difficult for some organizations, right? Some of them are going overboard. One of the things that I like that I'm seeing a lot of major vendors do is they're basically setting it up to where it can send a code to a device that you control. So if I'm trying to log into Google, it'll say, go to YouTube on this device, and you'll get a code and then type it in now, and then it'll authorize it. That's kind of cool. I really, really like that. The only problem I have with that is I have a lot of devices. And one of the times, like Google will be like, I sent this code to the Samsung like tablet. I'm like, that Samsung tablet is in the back of our kitchen at our bistro. We've got a bistro in Sturgis, South Dakota called Brewberry Bistro. It's a coffee shop that my wife and I own there because we drink a lot of coffee. And it's fun for our employees. It's one of the perks for working at BHIS is, yeah, you get access to the hacker house. Anytime you want to go with your family, you can go down to Costa Rica and go surfing. And you also get access to the coffee shop, and you get access to the coffee shop, which is next to the climbing wall at our office there in Sturgis as well. So we have these things, right? So, but when it sends the token to some device that I have in the coffee shop, it's not helping me out. It's not helping me out at all at that point. So a little bit of problem, right? A little bit of problem. But when we're breaking into environments, we use password spraying all the time as a technique to break into computer systems, right? And what we'll do is we'll try a password that's more than likely going to be used, like season and year. And this requires the attacker to harvest potential user IDs in that environment. And that's really easy to do externally. And it's also really easy to do internally. It's much easier to do, as a matter of fact, internally as well. The attacker then feeds those IDs through a tool like Burp, or they're going to run something like Cred Sniper or Password Spray Toolkit or Mail Sniper. We have all these tools that we use for doing password sprays in that environment. You're going to be doing this in a little bit with a lab that we have. So our time to compromise on this depends on the size of the network, right? Bread and butter for most attackers, a remote or medium organization, the numbers have changed. My testers have told me the numbers have changed, but usually around a 10,000 person network, 1 hour, we're going to find someone with season and year. That's all it takes, just 1 hour. My testers have told me this is now down to about 1,200 users. If we do password spraying in an organization with about 1,200 users, we're inevitably going to find a password that somebody is using. We just spread them out and we run them really, really, really slow. At this point, is password of 2025 feasible to spray on the internet? Yes, it is, George. I would try winter 2024. I would also try winter 2025, and I would try spring 2025. Those would be the big ones that I'd choose. Now, let's say that somebody isn't going to allow dictionary words, though. All right, let's say that someone says spring is a dictionary word. I'm not going to allow it. What would they do? What would a user do? Think about this for a couple of minutes. What would a user do to change that password to make it more usable? They would do leet speak substitutions. What does that look like? Well, an S could turn into a $, an I can turn into a 1, and so on, right? You would see that in a number of different ways. And then once we're in via this technique, we're very, very, very difficult to detect as attackers, very hard to detect. So we use cloud providers as well to bounce our password spraying attacks off of as well with tools like CredKing and Fireprox. So this is what password spraying looks like in something like Mail Sniper. We would try to go through and we would enumerate a bunch of potential user accounts in an environment. And then we will try a single password. In this situation, this is an old screenshot, summer 2016, but the same command works. And then it'll try to authenticate to each one of those user accounts with that password that we're trying to get in. So we've got some problems with passwords, short passwords. We go back to the NIST Green Book. Far too many organizations are looking at password complexity policies between 8 to 10 characters. Even the recent PCI password complexity is like 7 or 12 characters. What is the new PCI? Not PCI. What are the new NIST password policies? Take a few minutes and let's go hunt that down. What is NIST saying that password complexity should be, right? Is that good? Is it bad? Some of the new NIST standards are actually moving very much into the right direction, right? And I think that that's a positive improvement, right? But we still have far too many organizations that are running these things with ridiculously bad password complexity standards. And they believe that sometimes it's okay to do a reduced password complexity because you're using two-factor authentication. That is only a good way to do things if you can prove with 100% certainty that every single API and endpoint everywhere in the entire environment is using two-factor. By the way, it's not. Many times you have different APIs that are exposed that do not require password complexity coupled with two-factor authentication. So you need to make sure that this is set up on every single API endpoint all the way through your entire environment. So we have hidden two-factor authentication bypass techniques that show up all the time. Most of that is because of devices like this, right? Your phone. You have your phone and it sets up two-factor authentication. That's great, but you may not require all of the hard password complexity because people are accessing different services through their phone. And they'll say, well, they can just log in with the user ID and password with our corporate app. Well, the attackers can still gain access to those API endpoints and attempt to do password spraying. We also see things like Outlook Web Access. We also see things like Exchange Web Services. This would be an example where Outlook Web Access requires two-factor authentication for some users, and Exchange Web Services does not. Same portal, two different ways coming in as well. The only thing that matters when you're dealing with passwords is length. And you should never reduce the length of your passwords based on two-factor. Move to passphrases. So if you have something like exclamation point, I graduated from Wyoming, and then you give a phone number, and don't use that password, right? It allows users to use dictionary words, allows them to run things that are longer. It also is really cool to require a special character or an uppercase, but let them use dictionary words as much as you possibly can and make it long. Then it becomes a natural thing for someone to type. Two-factor authentication, something you know, something you have. I'm about to get spicy here. You have token-based authentication, you have SMS-based authentication, and you also have app-based. All of these are better than no two-factor authentication at all. Let me reiterate that. All of these are better than no two-factor authentication at all. The reason why I'm stressing this is there's a lot of people in the industry that poop all over SMS-based two-factor authentication. Google, thankfully, is going to be phasing this out here quickly, but that is still light years better than not having it. Yes, an attacker absolutely can clone a SIM for a phone and get the two-factor authentication messages. You can absolutely spam a user with annoying two-factor authentication things. You can do all of this. But the level of effort required to an attacker to break into a single account is still exponentially higher than just doing raw password spraying against an environment. So while I would recommend that you don't use SMS two-factor authentication for standard home users, yeah, that's probably just fine, because your general rank and file attacker is generally not going to go through SIM cloning to break into your aunt and uncle's accounts. The other thing is service accounts. These are oftentimes forgotten in many environments. They're accounts for services, and many of them are no need for lockout whatsoever. And they also have the need for passwords that stay running forever, because you can't change service account passwords every single 90-day session. And oftentimes they are overlooked. And there's tools out there, talk about a little bit with techniques like Kerberoasting, developed by Tim Medine of Red Siege, that allows you to take advantage of that in organizations as well. So this is a tool called Rubis that does that. It does Kerberoasting style attacks. How does it work? Well, it turns out that any user account in an environment can request a token granting ticket, or ticket granting ticket, for a service account. And within that ticket is the password hash. You can extract that password hash from that ticket, and then you can crack it. So if somebody could do me a favor, pull down, you can look at Tim Medine's webcast on this. If you just do Kerberoasting Tim Medine, it should take you to the Antisyphon website on YouTube, and you can see his presentation on what Kerberoasting is and how Kerberoasting actually works. Another thing that we can take advantage of is link local multicast name resolution, MDNS, and NetBIOS name services. I spend a lot less time on this now because Amazon, where our labs are running from, they don't allow us to do layer 2 attacks on this, which kind of sucks. But the point is how it works. I tell you what, how about after the lab, I'll explain Microsoft Cocaine and how LMNR came about. Does that sound good? Does that sound fair to everybody? We'll do that. All right. But the point is, it's relatively easy on many environments to intercept people's password hashes because of these protocols. And I'll explain how these protocols work as well. Other tools, CredKing, this is completely available by You Stay Ready, and it allows you to do password spraying by doing IP address rotation via AWS Lambda. Bypassing 2FA, setting up a phishing site that's using EvilJinx that allows you to intercept that token. So it forces the user to authenticate, intercepts the two-factor authentication, and intercepts that session identifier so that you can access their account as that user. Password managers are the bomb. Everyone should use them. Please use them. I have LastPass here. I probably should remove that. LastPass got into a little bit of a kerfluffle because a lot of their security was released. And it turns out they were using things like electronic codebook mode for AES, which is, you don't use electronic codebook mode for AES. Let me give you an idea how bad that is. You know the difference between ciphertext and plain text. I have plain text, it'd be like password. The ciphertext would be the encrypted representation or the hashed representation of that password. If you're using AES with electronic codebook, if everyone has the same password, the ciphertext will be the same for every single user. So you'll be able to say this is a very, very, very important password across the environment. We use Secret Server at BHIS. There's a bunch of them out there. You know, if you have friends, if you possibly could talk to people, go on Discord. You know, we can hit up the Discords and we can ask them what they recommend. That's always fun. All right, let's jump in. Now, privileged identity managers are really cool. With a privileged identity manager, it allows you to randomize the local password for different like high-level administrator accounts. So Microsoft has labs that like changes that local administrator password for every single system. BeyondTrust, CyberArk, and Centrify has the same thing, but you can put in your privileged service accounts, your privileged administrator accounts, and you can totally do the same thing. However, one of the problems with these particular services is you're kind of putting all of your eggs in one basket. And that is very, very true. And there's always risks and trade-offs associated with this. For example, take a few moments and go check online. Was there anything that happened with BeyondTrust recently? Go look it up. Yeah, there was a vulnerability in BeyondTrust that the attackers were able to take advantage of, and they were able to reset any arbitrary account at the Department of Treasury. So that was absolutely a problem there as well. All right, so now we've got the lab for Hashcat, and then we're going to do another lab for password spraying. We'll do these each separately, okay? So we're going to do Hashcat first, all right? So we're going to do password cracking. So we understand what password cracking actually looks like. We're still going to disable we're going to disable Defender on the system. We're going to become root. We're going to move into our system. We're going to go into opt password cracking. And then we're going to run Hashcat, and we're going to crack some passwords on our Kali box. So get that ready to go. And I'll walk through this, and then we're immediately going to pivot around, and then we're going to show you what password spraying looks like. So that way you'll know what the two main password attacks actually look like. All right, let's go through this lab. All right, so we're going to go from this lab, and we're going to jump straight into another lab, which is much faster because there's no break associated with it. So we go over here. I'm going to start up the lab as well. So once again, we're starting with disabling the antivirus, and honestly, I think that that's just a carryover of the previous version of this lab because seriously, we don't need to do that, but that's okay. So it doesn't hurt anything. It doesn't just weird. But we're going to get into our Linux computer system, and we are going to we're just going to do some password cracking. Now, I wanted to point out that getting this particular lab to work is kind of interesting because we have a scenario where we're running a Kali instance doing password cracking with a tool called Hashcat that really wants to use a full GPU setup. So let me explain a little bit about what GPUs are and how they actually work over the next 100 seconds. So if we go way far back in the time, I'm a huge fan of like retro gaming. I don't know if anybody else is. I don't got this really cool Anbrick little retro gaming handheld. This has like almost every game that you could think of, which of course I have full licensed copies of all of the games that I have on this. But I've heard, at any rate, these are awesome. And if you go back in time, right? Like if we go back to some of the earlier DOS games, like Space Quest, right? Those types of games, you would be dealing with the limitations of your CPU. So the graphics that you would get in the computer would be completely dependent on the CPU and what it could do. And then eventually what they did is they found out that you can offload the graphics processing to a graphics processing unit, which is a little bit of a misnomer because it's not a graphics processing unit. It's actually multiple CPUs working in parallel. This gets into something called floating point arithmetic. So whenever you're dealing with graphics on video games and things like that, you have a situation where it's doing the same function again and again and again at a very high rate of speed. Think of like ripples through water. Think of like wind going through hair or grass. You're doing the same functions again and again and again and again. So instead of making the CPU faster, where it can do it faster and faster and faster and faster, you want to do that in parallel across multiple GPUs, which are much less powerful CPUs, but you have a lot of them working in conjunction with each other. So that's how it works with video games. Now, how does that apply to password cracking? Turns out it's the exact same thing. Whenever you're cracking passwords, you are doing the same function again and again and again in massive parallelism. So I'll be doing something like trying to crack MD4 for an NT hash on a Windows system, or I'll be doing DES encryption of the string KGS exclamation point at pound prompt dollar sign using your password as the key again and again and again and again. So that's why this works so well for password cracking. So that's why GPUs work, which brings us to this lab. We're running Hashcat and we're running Hashcat in the cloud in non-GPU systems. So basically I had to trick Hashcat out by installing OpenCL drivers from Intel into it thinking that there is in fact a full GPU cluster. So it'll try to crack the passwords, which by the way, I don't know if anybody noticed the passwords that we run here are like some stupid, easy passwords to crack. And that's intentional with that as well. So let's go ahead and let's make this session, let's make it bigger, bolder, beautiful. So we're gonna go ahead and change that. I'll kick it up to a size 18 font. I think a size 18 font works for most of my classes. We're gonna make it bold yet refreshing, just like the mountains where your instructor is born. All right, here we go. So we got that. And we're going to become root, because root is root. There we go. And we're going to cd into the opt password cracking directory, like so. Then we are going to go hashcat. I'm going to run these commands. And I want to share something here with everybody while that's running. We have a hashcat cheat sheet. Here we go. And I'm going to share this with you all. There we go. And you can download it here. And it breaks down what all of the different switches are and what it does. So if we're looking at this, we're running -A, which is just straight mode on this as well. Oh no, I think it got a wee bit of a typo in the lab. All right, there we go. So we're going straight mode with our password cracking. Yeah, I'm pretty sure there's a typo because it didn't crack anything. And that's because all of the passwords are there. So I'll show you how you can do -- show to display the passwords that are actually cracked. So we get to spend a little bit of time learning how John the Ripper actually works with this as well. Okay, so get that going. I'm going to open up another Kali instance. And we are going to do this, make this one bigger as well. Change the settings, change the appearance. Once again, we're going to set this to size 18 bold, like so. Then we apply. And we are going to run the John -- well, we're going to show you where the pot file is. Waiting for the update DB. Like that. I know that this sounds funny, but stick with me. We're going to locate the pot. We're going to grep John. There we go. So I'm going to remove this file right here. And then we can try to rerun this command. Right. Don't know why that should have my update DB not work. Well, here you go. I guess you run into problems with labs every once in a while. I think I know what happened. I think we snapshotted the VM after password cracking, and it's not going to re-crack passwords. It's already seen. Okay, so this one's going to work, and we'll just go through it. I just got to update the VM. So if you hit status, it tells you how many passwords it's actually cracking on that. And it's trying to crack net NTLM passwords. There we go. All right. So there we go. Getting some of those. So let's go through here. So what we're doing with this, and once again with that Hashcat cheat sheet, is we have to specify what is the type of password that we're cracking, right? So if we're looking at the lab, the first type of password that we cracked, we're giving it like what the mode is or what the type of hash is, and it's a straight MD5 hash. So M0, if we go back to our Hashcat system here, MD5 is 0, right? The next one that we're going to be cracking is the NT password hashes. And for that, that is 1000. Right here, go down. We're doing 1000, and that is the NT password hashes, which is kind of funny because the NT password hashes are just straight MD4 password hashes that you have there being able to crack it. And we have Freedom 8675309 and so on with that as well. So pretty cool lab for us to crack some passwords. I've got to go in and do some updating to blow away the john.pot file, which I want to run the update.db command to figure out where that's actually being stayed, because it didn't update completely for me. And then I'm just going to add a line to the lab to blow it away. So then this never happens again on that as well. So when we're looking at password cracking versus password spraying, they are two separate and completely different things. So now we're going to get into the next lab, which is the password spraying lab, which is a different way to attack a computer system. Password cracking is where we already have a password hash, and password spraying is where we are going to attempt to run the exact same password against multiple different user accounts on an environment. And that's assuming that someone's using a password of season and year. Now, this one we are actually going to stay within the Windows system itself. So we'll be staying in that. So just keep that in mind as we're going through. So we're going to disable the antivirus, cd into the intro labs. We're going to create 200 users on the computer system. Then we're going to open up PowerShell, set the execution policy to unrestricted. We're going to open up local password spray, which is a variation of domain password spray by Bo Bullock. Then we're going to invoke local password spray with the password of winter 2020. And then you're going to see it cracks a handful of more passwords. Then we're going to remove the user accounts. So this lab is a little bit shorter. We're just going to take 15 minutes on this lab, and then there's going to be a break again because we're kind of at that point. So there'll be a 15-minute lab followed by a 10-minute break. We're going to come back and we're going to start talking about, what are we talking about? We're going to talk about egress traffic analysis to close out the day. And tomorrow we're going to start with a lab where we're going to jump right into Rita and AC Hunter. All right, so there we go. And I've got to make some changes to the GitHub repository for the password cracking lab. So sit tight, I'll make those changes. I'm going to pause screen sharing while I'm doing that, and I'll do that while you're doing the lab. All right, so get rolling. If you need anything, let me know. We will be back in 25 minutes. All right. So let's quickly go through this lab. Let me zoom my share so you all can see my screen coming up. Here we go. All righty. So we are back. All right. So what we're going to do is we're going to do some, do you want me to redo the password cracking lab for you guys? So you can see what that looks like since I fixed it. How does that sound? Should we do that? Let's do it. All right. So I'm already in, the first thing I do is I become root, which I am already. And this is the problem. I snapshotted and redid the VMs before this class, and it creates this pot file. And this pot file has all of the old passwords that it's cracked. You don't want to waste time actually cracking passwords that you've already cracked. So John the Ripper and Hashcat and all of these tools just don't. And it all started with John the Ripper. They created a pot file, .pot, and then Hashcat has a pot file as well. So I added in the instruction to delete that. So now we cd into the opt password cracking directory. And then we do the single crack. We're going A0 single crack. We're doing, the mode is going to be 0 for MD4. And then we're going to use these rule files. Now the rule files are interesting because we're going to be using leet speak substitutions. And we're going to be cracking the passwords in the MD5.txt file. And then we're going to be using a password list of password.lst. And down here, you can see it now cracked it. So now it's got tiger, it's got swordfish, it's got peanuts, it's got thrasher, and love123. All right. Now, let me show you what happens when you try to crack that same password again. You get the exact same thing that happened before I actually fixed the lab, right? So it's saying, hey, I've already got these. There's no new entries. And you can do the -- show at the end to display them like so, and it'll show you the passwords. But if we want to crack them again, you have to go through and delete that pot file. Now, the next one was using the MD5 or MD4 password hashes for NT. And these are the types of passwords that Windows hashes will look like. All right. So we're cracking a sam.txt. Takes a few seconds. It got it got 8675309. It got password. It got Fender. It got Rabbit1 as well. So it cracked those. And once again, if I try cracking those passwords again, it's going to just basically take a couple of seconds and then it's going to give up. And it's basically going to say, hey, I've already cracked all of those passwords. So the trick for this is to remember, if you want to rerun these labs later, you got to remove that pot file. Once it's gone, it goes in and it starts cracking the passwords like a champ again. All right, so that is the password cracking lab. So now let's move on to password spraying. All right. For that, I'm going to open up a command prompt. All right. And I'm going to go to the password spraying lab. It's like saying, quick to the command prompt. Here we go. Shut off my AV. There we go. And now we're going to cd into the intro labs. Thusly, we're going to generate 200 users on this system. like so. And then we're going to invoke PowerShell, which takes just a second. Just 2 shakes of a lamb's tail. It'll complete out. Now we're going to invoke PowerShell. Then we're going to set the execution policy unrestricted. This just basically allows no security for any of the PowerShell scripts that we're executing. We're going to import the module local password spray.ps1. And now we're going to run our command. So we're going to invoke local password spray with the password of winter 2020. And let's zoom in before we do this to get the excitement. Need a little spice, need a little excitement. And there you can see we were able to identify a bunch of user accounts. We got Christopher, Dennis, Gregory, Jack, Jerry, and Michael. Now, let me explain why we do this and why it's actually important. We do this because when we break into a system, we usually start with a low privileged user account, right? And it's usually someone in accounting or someone in a development team that's not running as administrator or whatever. Somebody is doing something at this company, but they're not really a powerful account. So we do password spraying when we're pen testing so that we can identify additional other user accounts by using this password spraying attack. Now, if I run this in an environment with 1,000 users or 10,000 users, the odds of me finding someone that has access to sensitive data starts going up quite dramatically. It may not be an administrator, which is fine, but they may be somebody who is a very high powered account in some type of application. Let's say that they're actually the director of finance. That's not an admin, but that's absolutely an account that I want to gain access to in this particular computer system. So that's why we do password spraying. This also is going to show you a little bit later whenever we start talking about logging, the types of logs that are required to successfully detect these types of attacks in an environment as well. All right. So that is that. Now, at the end of this, we're done with labs for the day. What are we all doing, folks? What are we all doing now? We're at the end of the day. What are we doing? We're going to destroy our labs. All right. We're going to do destroy labs. There we go. And I'm going to show you something else. Go here. All right. So we have something else in this class. We also have a pay what you can training certification. And I'm going to spend a few minutes talking about this and how this is set up for you all and why this is different. Because you're taking this class, and I think it's really important that you work towards getting an ATT certification. And this is the part where Zach and I like to talk about how much we hate multiple choice tests. I hate multiple choice tests. I abhor multiple choice tests. There's a lot of history out there that goes into great detail about how multiple choice tests are actually a horrible thing for being able to adequately test someone's ability at actually doing anything. It goes all the way back to World War I. In World War I, they tried to use IQ tests and multiple choice tests to try to identify which officers would be the most successful in the field. So they gave them these tests. And it turns out those tests had little to no bearing as to how successful different commanders and lieutenants would be in the field. However, by the time that that data was completely kind of taken in and digested, it was too late and the bug had been set. And you start getting a number of people that like to look at these multiple choice tests as a valid indicator of someone's, I'm just going to say it, someone's worth. Okay. Now, back to Zach and I and our intense, deep hatred for multiple choice tests. It seems like the entire industry has been completely enamored with the idea of multiple choice tests, where you go in, you take the test, and then you get certified, and somehow that is some type of qualification saying that you know what you're doing in a specific area of work, and that's garbage. Once again, we've known this since World War I, and we continue to be completely enamored with the idea of getting a test and identifying someone's worth. So to that end, you have a number of certifications that are multiple choice certifications that are very expensive certification tests that are out there. Some of them charge hundreds, sometimes up to over $1,000 for a certification test. And this pisses me off. The reason why, oh, there's a $5 for the swear jar. And the reason why this makes me mad is because it basically takes this test that means very little to someone's overall skills. It becomes a steeplechase to get through the front door to get someone so they can actually try to get a job, and it doesn't work, and they charge a lot of money for it. So it literally becomes a barrier that exists for one specific purpose in life, to prove that you can afford to take the test. And that, my friends, is not what we are all about. So we created our own multiple choice test. I know that's weird. I just got done talking about how much I hate multiple choice tests and how much I hate them. And then I said I created one. All right, so let me explain what we've done. When you log into MetaCTF, you can scroll down and you're able to see the ACE-T core certification. We created a multiple choice test. Now, this test is pay what you can. I can't remember what is the minimum value? Isn't it like, what is the default cost of this test? I know a bunch of you went through and you can tell me, went through this. It's $5. $5. And the reasoning for that is I can give away my stuff for free, but I can't give away MetaCTFs, and this requires some infrastructure on the back end. So it's a $5 security certification. So here's what I'd like you all to do. And I know $5 for some of you is an absolute, it is a matter of money, but I would hope you can afford $5. I sound like a TV charlatan. It's like, if you can afford $5, this goes to like making this thing actually run. And I'm going to show you why. So in this, you can start a new attempt, and it's a multiple choice test of 100 multiple choice questions. You have 2 hours to complete it. All right. Now, at the bottom of this, it says step 2. After you have passed the exam, you will be assigned 10 hands-on CTF challenges in the Antisyphon cyber range. You will have to solve at least 5 of them to obtain the certification. You will have to upload 2 write-ups for the challenges that you're able to solve. Even though there is no time limit for this step, you're only going to be given 1 week to access the cyber range when you begin. These write-ups will become publicly accessible with your certificate when people check in on you and your overall skills. So you'll be able to provide a link that says, I'm John Strand, I am ACE-T core certified. And then there will be a write-up of the quality of work that you do. So your representation of you as an individual is not just your ability to pass 100 multiple choice test, but also it's going to be solving cyber range challenges and doing a write-up on this as well. You know what? It doesn't. Roswell, UK, don't care. You can make your write-up as garbage as you want it to be. By the way, don't use AI to write it and copy and paste from other people. We have some checks for that. But you can make it absolute garbage. You could make it nothing but this sucks. It's fine. But remember, your certification isn't just a certification. The people that were looking to hire you will pull this down, and they'll be looking at your work effort, and it'll be a representation of your skills as well. So it's not an issue of just you're certified, congratulations, you pulled the wool over our eyes. It's basically, you got to put some work into this, and you got to prove that you can actually work and effectively communicate as well. If you want to know what an interview report looks like, Brian just shared one out, the pre-interview report. So yes, I hate multiple choice and multiple guest certifications. Can't stand them. I hate the fact that people charge hundreds, if not over $1,000 to do these stupid things. So I created one, and I made it as cheap as I possibly could to help burn the freaking bridges down. So you guys have this when you get logged into MetaCTF. Let me go back here. When you first get logged in, you'll see it at the bottom on this page as well. So if somebody can, let me see. I think I can actually access the portal. No, that's my link. You don't want that. So we'll get some instructions for that, but there are there. If somebody could screenshot where it is, because if you're in Cloud Labs, it doesn't show it. You have to go back to the core MetaCTF link, and then you can acquire it down there. And I thought we had some, Brian, I thought we had some instructions in my Intro to SOC Core Skills class that Zach put together. Can
I was
you
just downloading now.
Awesome. And then we're going to put that in resources that has step-by-step instructions to get that uploaded, and we'll get you all loaded into this. My goal is to get as many people certified in this certification as I humanly can, because the idea of an introductory cert, like I said, costing hundreds of dollars, literally you're just paying for people that are already fairly wealthy to get more wealthy. So let's help me burn those bridges down. And the way you do that, by passing this thing, getting the write-up there. And did you get that in resources too, sir?
For some reason, I can't post in resources.
Again?
Yeah, somebody doesn't like Kiwis.
All right. I am going to upload it to resources then. Just give me a second. I can drag it and drop it. There we go. All right, there you go. You all now have the full instructions on how to get started. And it should be in resources for you all. And you got full instructions. So please do that. And by the way, if you took the SOC core skills and you're taking this class, that's all going to help you get set up and get rolling. I did have to charge money for it because we did open up the ACT sort of like cyber range. So it's not just answer a bunch of questions. We have to have some money to get these things set up as well. So, all right. There we go. Now we got the instructions. So that is, so the next thing that we like to do in this class, since I don't have a lot of time to go through egress traffic analysis, we'll start this tomorrow. But I do want to do the Ask Me Anything. We like to close out the sessions with Ask Me Anything. If we can put Discord up on the screen instead of MetaCTF, feel free to ask me anything, anything at all. I'm trying to figure out what the hell is that? That's strange. So I'm here to answer any questions about life, the universe, and everything, computer security. We can go through the labs as well. How do I get better at incident response? Well, a lot of the things that we covered in the SOC Core Skills class, and if you didn't get a chance to take the SOC Core Skills class, it's archived out on YouTube, and the labs are the same. Lake Show, you know. So if we can get a link for that previous session on YouTube, you can go through, and if you can learn those Windows command line, Linux command line, networking, threat hunting, and tomorrow we're going to get into network threat hunting again for this class, that'll really help you get better at incident response for doing those things. So you're in the right place as well. Taking certain certifications feels like acronyms are more important to know than actually learning. I agree. There's a bunch of training classes and certifications that are basically like man pages and like knowing acronyms. And I think that that's kind of crazy as well. Don't see a careers pages on the BHIS website. How do we get an interview with you all? We're always hiring and we're never hiring. It's basically do really well in the cyber range and be a great person in the community, and you're going to get there. In fact, we have the time traveling nerd herder. He came up through here. So we hired Brian because he was just an awesome person and just awesome with other people. And you guys have seen HK coming and going. I don't know if HK is still on right now. It's getting pretty late for him. Although Brian has no sympathy for people that have trouble with time zones. But yeah, it looks like HK went to sleep. But HK is one of our nerd herders that we just hired. So if you get a chance, send him a congratulations. It's really, really cool. How many remote employees do we have? Right now, we have 160 employees at Black Hills Information Security, and I think we only have 20 in the Black Hills, so we're all over the place as well. How do I get better at vulnerability management? Kat, you get to the vulnerability management section of this class. Vulnerability management isn't as hard as you think it is. There's one easy trick that changes the game completely for vulnerability management on that as well. Need to do my write-ups. Mine looks like crap comparatively. Yeah, it's all work. Go to a local university and go to their, like, I don't know, sometimes you have to show your student ID, but a lot of universities have writing workshops or TAs that help with writing. The other thing is go to this website called No Red Ink. It's a fantastic resource. Not good. And it'll really help you get better at writing. It's noredink.com as well. There you go. All right. HK is sleeping. Slacker. All right. What are my recommendations for learning more about bug bounty programs? I would recommend taking BB's class on web app pen testing because most of the bug bounties that you're going to find are going to be based on web app vulnerabilities as well. So, there we go. What tips do you have for finding local InfoSec communities to connect with people? I moved to the greater Rapid City area and I'm looking for more people in this area. What you need to do, Nicholas, is look at the local InfraGard chapter at Rapid City. That is the best community in Rapid right now. So look at InfraGard as well. Is there somewhere we can find a list of terms and what they mean? Medic triage means something different as it does in computer security. Triage is pretty much the same thing. Stop the bleeding, right? You have something and you have to do like, what are the immediate things to stabilize a network? That's triage. What are the immediate things that you do to stabilize a patient? That's triage. So very much it is the same things. There's just, you're trying to stabilize a network or you're trying to stabilize a patient as well. I'm a SOC analyst currently, want to do better with KQL. What pre-built SOPs? What can I do? There's a number of KQL classes out on Udemy that are pretty solid. That's Kibana. For those of you that don't know, it's part of an ELK stack, Elasticsearch, Logstash, and Kibana. So that's number one. The other thing that I would recommend, Lake Show, is you can learn KQL. You can also learn Sigma. If I do Sigma log analysis, there are a ton of different things for Sigma. And Sigma is a tool that allows you to learn how to write signatures in Sigma, and then it will actually output the KQL for you. So Sigma is kind of like a Rosetta Stone. So please check that out. If anybody else has any recommendations for Sigma training and trying to do that, share them with that as well. Is it possible and unusual for an European to work remote in this field in the United States? No, it's not. As a matter of fact, just last week, BHIS Poland, Black Hills InfoSec Poland officially became a thing. We have an official company in Poland. And then we also have a GmbH in Germany, which is Black Hills or BHIS Germany GmbH. So we've got to get the bank account information set up and then it's official. So we are actually opening up branches in Europe. So it is coming as well. All right. What other questions do we have? Did that one. Did no red ink. We got a bunch of people helping each other out. That's great. If you want to make it a little bit easier for me, if you have questions for me, do @StrandJS. So it's very easy for me to hunt that down as well. I'm responsible for a small nonprofits network. If I suspect there's an attacker, do I use Zeek AC Hunter? Yes, you can use AC Hunter Community Edition. Like that. And this is free for everybody. And we actually have instructions to set this up in an environment without a managed switch. If you go back to the intro labs, we have AC Hunter Community Edition right here with step-by-step instructions to get it running in a lab and then using BetterCap to do the ARP cache poisoning on the network, so you can get full Zeek sensors and get everything set up. So I have all instructions on that, and it's all ready to go for you as well. Okay. Will I teach detection engineering? We actually have a class by Connor that has detection engineering. It's not one of the classes that I teach yet. All right. Does AC Hunter have host EDR too? No, it does not. However, you can do AC Hunter and you can integrate it with, if I go over here to free tools with SB. SB is a tool that allows you to integrate your sysmon logs with Zeek, with Zeek and AC Hunter. So that's pretty cool. Is there a limitation to AC Hunter Community Edition compared to the paid one? There is. If you scroll down here, it shows you what the differences between the two are. So we have that completely broken down on what the differences are. But for small, like nonprofit or home, it works just fine for what you're doing. I'm curious to advice you have on balancing training and learning with toddlers committing to pure chaos. I actually really jump-started my entire career when I had toddlers. So I remember kind of a life-changing event for me is I was watching American Idol. It was the one with Justin Guarini and I can't remember the other lady's name. And they were doing their whole song and dance thing, and I was watching it on television. And then I heard my a thump, and my young daughter had walked across the room, and I had missed my daughter's first steps because I was watching TV. So I pulled a whole sort of what is it? What was that movie where they threw the TV outside of their hotel room? Poltergeist scene, and I was done. So I kind of gave up on video games and I gave up on television. I dedicated myself to this. So yeah, you have kids, right? But there's also a lot of time you spend doing casual things. And I hooked myself into learning computer security and getting as good as I possibly could with it. And that was right, like the year where I learned the most was the year that I had, of course, my first daughter, then my son, then my youngest son, which is literally right through toddlers. So here's what I recommend that worked for me is bound yourself. So what you want to do is say, this month, I'm going to dedicate myself to learning Windows command line. I'm going to learn Linux. I'm going to install Active Directory at home. I'm going to do these things. And then at the end, I'm going to take a month off. I'm going to watch things on Netflix. I'm going to, play video games, whatever it is. But you're going to set it for a specific period of time, and you're going to give yourself an endpoint. And at the end of that endpoint, you're going to do something for you. So that's what I recommend doing that as well. Are you worried that Elon Musk and his employees have access to all government agency systems? I'm going to be talking about this on the news, and I'm going to try to scuttle away from the politics of it. So a couple of quick things. I think that the idea of government efficiency is really important. I think that we should be trying to make sure that our government is serving us the best way it possibly can with the least amount of waste. That being said, this is not the way to do it. You don't give an unelected official that went through no background check and went through no vetting, who got 5 more people with no background check and no vetting, access to every single effing system out there for finances in the United States of America. This isn't a Republican issue. This isn't a Democrat issue. This is just a blatant stupidity issue. And let me explain why. You may agree with what they're doing. You may not agree. Personally, I think the government's bloated. I'm going to give you let me give you an example where I'm coming from. Because some people are like, I don't agree. John is mad, so therefore he must be a never Trumper or whatever. Okay. So when I worked at the Department of Interior, I was in charge of computer security for large sections of it. And I had access to the web logs, the web proxy logs of what people were doing. And I could see like how much work they were actually doing. And I can guarantee you that probably at the time that I was there, 50% of the people were surfing the internet to non-government related websites for 8 hours a day. All right. That made me mad. And that made me very jaded about, oh, well, the government, they're inefficient. They're doing all of this stuff. And I think that we should try to do something about that. I tried to go to my COTAR. And my Kotar was basically like, yeah, we can't fire these people because they're GS1 too manys. And some of them are, we just won't be able to. It sounds like work. We're not going to do that. That made me angry. So I'm completely in alignment with the idea of a more efficient government workforce. That being said, unilaterally going through and just laying off probationary like employees is stupid because you have people that are moving from job to job. You have a lot of veterans that are moving from service into government work. You don't go at it with a freaking chainsaw like Elon Musk is doing. But now let's boil it down to the security side because that's what really matters. All of these things, bureaucratic red tape, this is something Jake Williams said. Bureaucratic red tape and all of these things are also controls. Abraham Lincoln had a great quote whenever they talked about telegraphs. They said that we can actually make decisions at the speed of light. And he said we could make mistakes at the speed of light as well. And right now, unilaterally doing all of this is completely destroying the integrity of the data in the United States government computer systems. So if you ever get into a situation where you're in a court of law and you have somebody who goes by the name Big Balls in charge of that data, all of a sudden, all of that comes into question and it becomes harmful. Okay. So there you go. You tried to get me in this. There you go. You got it. Great job. You got me going. And please don't take this to mean that, like, my politics, because you really, truly don't. If I had to take one training class other than my own, what would you recommend? Bo Bullock's Breaching the Cloud, I would recommend. Proxmarks, Kelly Clarkson. There we go. It was Kelly Clarkson. Michael Allen's is great as well. Boy, am I way far behind on questions. I'm just going to go to the bottom on this as well. All right. So let's talk about the hammers, because if you have a hammer and you go and buy it in the United States, that hammer is what? $25. If you're taking a hammer and you're buying a hammer and you're shipping it to Kuwait, it's not going to be a $25 hammer. So you've got to be careful when you're looking at trying to break these things down as well. Maybe I could offer Doge my services to help them out. I wish they would have done something like that. If they would have done something like, hey, we noticed that these percentage of people aren't working all day. We're going to get rid of those people. I'd be on that bus. I think we go on that as well. But I'd still want to make sure the people are elected. The government funds that organization, goes through the proper procedures as well. But that's important. All right. All right, going through more questions. Looks like I kicked over a hornet's nest, you guys. What would you suggest as a pathway to get a young person into cybersecurity? I have a really cool oh, yeah, that sounds really arrogant. I have a presentation called your 5-year InfoSec plan. So go check it out. It should help you kind of set that up and some things that you can actually do on that as well. Right. Okay, I did a lot. Okay, I may have kicked over a hornet's nest. Oh, looks like Slicker Spent got that. I was told the JP8 diesel we were using in Afghans for by a gallon. Yeah, I don't know about that. All right. So never let the magic black smoke out. Yeah, soldering is a good skill to have. What other questions do you guys have? Like I said, this last half of this class is all year, or last half hour is all yours. I recently got hired at my first InfoSec security job. What are some tips you have for us? I recommend Titanium. That now I got that Sia song in my head. That's great. Great name, Titanium. Oh man, now I'm going to be listening to Sia for the rest of the day. At any rate, so what I recommend that you do is learn what your key applications are in the job in the organization that you're working at, and then go to CIS hardening guides. Oh, right. Don't click on the sponsored ones. So these are the CIS benchmarks. So you want to go through and understand what your core technology base is for your organization. And then I want you to start reading those guides and getting an understanding of what are the security relevant files and different settings for those different things. And then taking a look on that as well. That'll really, really help you kind of accelerate your career on that as well. Zach, if you're coming in, we're just like all over the place. We've already
I,
talked about Doge and Sia and
I
all
was
that stuff.
listening.
So it's a good day. It's a good
Great
day.
day. How'd everything go today?
I think it went well. I had one little lab I had to update. The pot file for Hashcat was left over, so it wasn't cracking the password. So we just had to add a line to delete that pot file, and we're back in business on that as well.
All on the fly, and you got it done. Easy peasy.
That's what we do. We do
What
stuff.
what were the thoughts from everybody who are still with us on the class? What do you guys think? How did John do? You gotta like close your eyes, hide.
Yeah. All right. So then we did already walk through the ACT core certification. I think a lot of people are super excited about that too. So
I can send out a link for that if you want.
yeah, I think we've got your resource doc on how to do that has been loaded into resources. So thank you for that. Ooh, Psycho Killer. What's the other one? Life in Something. Life in Wartime is another just fantastic talking head song out there. It's great. Can it be done in the future? It can, but you only have 5 days after you start it where you get access to the cyber range to start working through those challenges. So be ready for that as well. All right. And also, Zach and I, we're going to talk about this, folks. We are going to take pay what you can training on the road here shortly. We love doing it here, but we were thinking, Zach and I were talking, like, what we should do? We should get away from our families more, Zach.
Oh
Uh,
yeah.
that was not the conversation.
No.
Uh, but in all reality, this is good. But being able to be in a room with your instructors and doing this is just, it's way better. And we're coming up with some crazy ways that we can do that. If you have friends or family that have connections at a university, and maybe we could rent some space during the summertime, let us know. But we are excited about trying to go on the road. We are not going to be going to hotels because hotels charge a ridiculous amount of money. But we are coming up with different ways to make this live and make this be with you all. So with that, let's go ahead and let's write it up. Let's close it out. And by the way, this will be recorded and it will be saved in resources. And we also have it out on YouTube as well. So I'm excited there. So once again,
Hang on really quick.
oh, you got something
PJ,
for us?
yeah,
Go for it.
PJ, between like 100, 200 people is what we're looking
Oh
to
yeah.
house for this training. So if y'all hear of anything, let us know. The first place
Yep.
that we're looking to go to is the DC area. So we're been sending a lot of communication there. But if you guys have anywhere else in the US where you are a part of a university, community college that has some space available, we can partner with you, please reach
Yep.
out to us. We'd love to work with y'all.
Going on the road. We're getting the band back together, which we never really, we never really broke up. But anyway,
Yeah.
I will have
Somebody
that many
asked in
seats.
Zoom, if the 5 days is expired, do they have to start the ACT all over again? I'm not sure on that one.
Yeah.
We can have them. I think they do have to start it all over again.
Yep, they will.
So,
So the answer to that, Michael, is yes.
yep. But it's cheap. I would be ready and do it. Like I said, we try to make it as accessible as we possibly could. And we're trying, really, our main goal, honesty, at the end of the day, we're hoping that by us doing a multiple guest test, that we destroy other multiple guest tests in the industry. If we can get people to be like, well, we can't do multiple choice because these guys are doing it for $5. How do we compete with that? And we're going to have to go out of business, or we're going to have to change our business model to be more focused on CyberRain's hands-on challenges. I think either of those outcomes, Zach, are good with us. Like if they can go out of business or they can evolve into something better. I think I would take either one of those, right?
100%. 100%. But it's so much more than a multiple choice question
It is.
exam, though,
It has to be. It has
Uh,
to be.
and that's where, I mean, this is where the multiple choice like question exams just fail like completely, is they just leave you at, did you pass, did you get enough right to pass, right? And it's fine. That's a great way to assess something to some extent. But I love the fact that we are making people go through challenges and actually write a report. Like just the report writing aspect of this alone really excites me because this is really the most unique way that you can put yourself in front of a potential employer to really stand out. You know, you're validating that you understand the skills through the multiple choice. You're validating your skills through going through these challenges. But at the end, you really validate yourself through writing that report and giving the detail and being, go ahead, John.
And somebody asked, they said, what if I did a crappy job on the report? Great. I'm not going to check your work, but all the people that want to hire you will.
Yeah.
So
that's what's exciting about it too. It's like, this is really giving the employer an opportunity to really get a good feel of you overall.
Brian pointed out this whole cert seems pretty similar to a certain company's hiring practices. Yeah. We like seeing write-ups, right? That's what we're looking for.
Listen, we've got the secret sauce model. Why break?
Why change it? Why
Yeah.
change? How can we donate funds to assist others with covering the costs of these tests? I tell you what, I want to ask you all a question. If we did a GoFundMe, because we have a lot of people that, you know, they pay nothing for this and they're like, crap, I wish I could have paid something, or they want to help out with what we're doing. If we set up a GoFundMe, would that be creepy and weird, or would you guys be okay with that as well?
Just set up a donation link on the website through PayPal or something.
Yeah,
we can do that.
When we redo the pay forward what you can, we will make that its own section.
We want to rename it too. We don't like the pay what you can. We want it to be pay it forward. Yeah. And I think that's what we might do. We'll look into it. I don't know. I think Zach and I are on the same thing. Like, isn't GoFundMe pretty much used, or Patreon, isn't that pretty much used for like OnlyFans, people with foot fetishes? I don't know.
I don't think so. Yeah. It's usually like
Patreon is not? Okay.
Yeah. I think that we should do just a link on, you know, the pay it forward on PayPal, and then because when you use other services, you have to pay all of the processing fees on their side. So if we just set up our own little thing.
Yeah. I don't know. I'll look at the Patreon thing maybe before the end of this. I don't know. But yeah, we're going to try to change this from pay what you can to OnlyFans. We're going to try to
Listen, if there's an OnlyFans with John Strand, it's not this John Strand. There's a different
one. There's a different John Strand.
Yeah.
And he may have that out there.
Yeah, I'm sure he does.
Exactly.
Come on now. You guys know I have these photos.
I know you do. I know you do. I know you've got these photos. You got to spread them out. You got to understand, when you're dropping that crap, it's got to be like fertilizer. You got to spread that crap out, Brian. So
Code Brew wins the day. I'm going to send them something right now.
I think that, oh my God, here they come. All right, everybody.
No, stop. Don't
all right, we're out of here.
Like
Thank you so much, everybody.
Thanks,
Talk to you all later. Bye.
Bye, John. Bye, everybody. See you tomorrow.
Bye, guys. See you, everybody. Have a good day.